Refresh my memory. Monday. What was the method we used for factoring? Greatest common factor, GCF. Does that ever go away? No, we look for it everywhere. It's super important. Then yesterday, what did we do? Grouping. And then when we were doing grouping, how many terms are there? 4. So today is going to be a very special method of factoring. It will not work every time. However, it will work frequently because it is in reference to quadratics. And quadratics are going to be our next 2 months of math. Okay? So it has a little bit to do with GCF sometimes. The reason it works is because of grouping. But it always looks like this. And x squared plus bx plus c is the standard form of a quadratic. So we are specifically talking about quadratic polynomials. And we say quadratic, what is the degree of the polynomial? 2. And what that means is we see an x squared. How many terms do we see? So the method we're learning today works with trinomials. And what that means is 3 terms. And this is very specific to today. The leading coefficient, or the coefficient of the squared term, is 1. So the true standard form of a quadratic is ax squared plus bx plus c. But in today's case, a will equal what? 1. So they don't have to show you because 1 times x squared is x squared. So just a humor me, if I told you x plus 1 times a different binomial equals x squared plus 3x plus 2, what is the other binomial? X plus 2. Yeah, and if we check it by foiling, this 3 also works, right? X squared is right here. 2x plus 1x is 3x. And 1 times 2 is 2. And that's nice because 2's prime. X squared, you can only get x times x. But what we're going to be learning about is that factoring isn't always that easy. If you look down at this example number 1, you're like, I know that I have to have x times x to get x squared. But 48 can be 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. There's 5 possible pairings that could go just for 48. So today we're learning about how to find out what those terms would be if there's more than one option. Okay? So we're going to use something I call the X puzzle. So you're going to hear me say, okay, did you use your X puzzle? Did you draw your X puzzle? But you just need to think of it as a little logic puzzle to find your terms. And what matters is we know that we want the product of C. So we're always going to put C in our product spot. What does product mean? Right, it's multiplication. So we said what multiplies to be 2. And I've just asked you what multiplies to be 48. And then we will note that to solve our X puzzle, we will also need to know the sum that gets to B. So steps for factoring. We already know that because x squared has a coefficient of 1, that my coefficient of x for both binomials will be 1. So I know that I will have a binomial x plus or minus something and another binomial x plus or minus something. Okay, so coefficients of x will be 1 for both binomials. So when a equals 1, we're going to have an x here and an x here, no numbers. In the x puzzle, we want c in our product spot, and we want b in the sum spot. So down here in example 1, what goes in the product spot? What will I put right here? 48. Okay. What goes in the sum spot? Negative 16. All right, so the first thing you have to do when you're thinking about your puzzle is you need to decide your signs. Decide signs. You can either have a positive factor and a positive factor, a negative factor and a negative factor, or you might have a positive factor and a negative factor. How will you decide? What do we know? If 48 is positive, what do we know about a positive 48 if it's a product? Two positive numbers can multiply to make a positive, yes, or two negatives. So we know it's not this one. We know we either have two positives or two negatives. So then after we decide, okay, do we have positive or negative, we say, okay, negative 16. Could two positives combine to be a negative number? No, so I know that I have a negative and a negative. Solve your X puzzle. What numbers multiply to be positive 48 but combine to be negative 16? And I heard someone say, oh, it's 8 and 6. But negative 8 and negative 6 make what? Negative 14. So that's not it. Let's try again. 4 and 12. Okay. Negative 4 times negative 12 equals positive 48. Negative 4, negative 12 combine to be negative 16. Okay. Now, this is a big deal about tomorrow, and I'm going to tell it to you now. This right here, negative 4x and negative 12x make negative 16x. We have a trinomial here. But to factor something, we're going to have to group. But how many terms do I need to group? 4. So I make this into two different terms, and then I'll have 4 terms. So these factors tell us how to split our B term, your middle term. So grouping is possible. So here I have x squared minus 16x plus 48, but I've solved my x puzzle, so I'm going to change it to x squared minus 4x minus 12x plus 48. Do you see how I kind of unsimplified my trinomial? I made it a polynomial with 4 terms. Remember, factoring is like working backwards. So these would be our terms for the first, outside, inside, last. Okay. So group. What comes out of my first group? What's left behind? X minus 4. What comes out of my second group? Negative 12. And we leave behind x minus 4. So my first binomial will be what? X minus 12. And the other binomial? X minus 4. Hey, look. Minus 4 minus 12. Grouping is not actually necessary when a equals 1 because your X puzzle will give you what you need for your binomials. However, I have to show you this because this step is non-negotiable when we have a does not equal 1, what we will do tomorrow. So I wanted to show you that that's how this works. Grouping makes this possible, but this step is unnecessary when a equals 1. Questions? You can always check your factors by distributing. And when we say distributing, I will most likely say oil. So example 2, we know that we have z squared, so I know I will have two binomials that start with z. What goes in my product spot? Negative 36. What goes in my sum spot? 9. Is it a positive 9 or a negative 9? Positive. So what multiplies to be a negative 36, but adds or combines to be positive 9?
12 and negative 3.
How did you decide that 12 is positive and 3 is negative?
Because 12 minus 3 is 9.
If this had said negative 9, we would have swapped those signs. It would have been negative 12 and positive 3. But because it's a positive 9, our bigger number needs to be the positive. 12 times negative 3 is negative 36. 12 minus 3 is 9. So 12, z plus 12, z minus 3. Could you say z minus 3 and z plus 12? Yes. So you could say z minus 3, z plus 12. Same thing. Same answer. Good question. All right, one more. Example 3. If I have 3x squared plus 39xy plus 120y squared. Ms. Webb, you said that today a equals 1. And what does a equal here? So what do you think we need to look for first? GCF. Our GCF is 3. So we're going to factor out a 3 first. So we have x squared plus what? 13xy plus 40y squared. Okay. Our x puzzle, now we're not going to worry about the 3 right now. It's just going to hang out on the edge for the rest of the time. But in our x puzzle, what goes in our product spot? 40. What goes in our sum spot? And what multiplies to be 40 but adds to be 13? 8 and 5. So we know the 3's out here. We know it's going to be x plus 8, but it's not just 8 because this is not just 40. It's got to be 8y because this is one of the y's, and then we have x plus 5y. So now we have y times y. That's how we get that y squared.